Hello students, today we are going to see Monte Carlo simulation method. The Monte Carlo technique, what we can see over here is that computational technique which is applied to static models, and what we can say here, samples we are considering in this type of simulation is on random numbers. So if we take example of this is the integral of a single variable ever given range correspond to the finding the area under the graph, which can see over here, and we can see this function of f(x) is positive and it is given over here, and it has two limits a and b. So let the function is bounded above by curve C. This is curve C. Okay, so we can see or observe this diagram. We will able to understand that the graph function is containing within a rectangle with sides C and B minus E, and what we can say, area of that rectangle is equal to C into B minus E. So if we take the point randomly within the rectangle, within this rectangle, and we can see if that point which is coming under this curve or beneath this curve, then it is treated as accepted, and if that point is coming inside the rectangle but above the curve, then it is treated as a rejected one. So we can see that providing the distribution of selected points is uniformly spread over the rectangle, the fraction of point falling on or below the curve should be approximately equal to the ratio of the area under the curve, that is f of x into dx, to the area of the rectangle, that is C into B minus E. So if we are considering n as the points, number of points which are used for approximations, and then small n is the number of points which are coming under the curve, or we can say which are accepted one. So here we can see the ratio of small n and capital N. It is under the integral from a to b f of x dx upon C into B minus A. So as we can observe this equation, to improve the accuracy, we can increase the number of samples, or what we can say, capital N, and when it is decided that sufficient points have been taken, then the value of the integral is estimated. So how can we estimate the value of integral? By taking small n by n ratio, or multiplying this with the small n by n ratio by the area of rectangle, that is C into B minus A. If we take this C into B minus A on the left side, then we can get the value of integral a to b f of x dx, and that is called as the value of that integral. So for each point, a value of x is selected at random between a and b, what we have seen over here, that is x0, and if we take the function f of x0, okay, then again we can see second random selection which is made between o and c. Here we can see o and c, then it is f of x0. Okay, so for that we will have the condition, that is y is less than or equal to f of x0 then the point is accepted in the count that is small n, otherwise it is rejected and the next point is picked. So this is the all idea for the Monte Carlo simulation. It is very much useful in simulation methods. So I hope you have understood this topic. Thank you very much.